Hello everybody and welcome to our video today where we will be talking about organic chemistry chapter 3, which deals with molecular bonding and hybridization. So this is kind of a short chapter in terms of important content, but as some of the other shorter videos, they definitely serve as the basis foundation of a lot of important things. So just make sure you understand these concepts as a whole. So this chapter starts by talking about the quantum numbers, okay, all of which describe the shape, size, and orientation of the electrons and their orbitals. However, we've talked about this in an earlier video, in one of the general chemistry videos. So if you need to go over that, go check out that video, the general chemistry video. I believe it's probably chapter 1 or 2, I'm assuming. But the organic chemistry part of this video really talks about the hybridization and the types of bonding. So if we're looking at types of hybridization, so we have sp3 hybridization, which means you can kind of picture this as this S is having a 1 here as its superscript, and a 1 and a 1. So this carbon would be bonded to 3 plus 1. So the carbon would have 4 bonds in sp3 hybridization. And this means that it's 25% S character, 75% P character. And that would give you tetrahedral geometry with a bond angle of 109.5. So again, it's sp3 hybridization. And this means that the carbon has 4 bonds. So you just count these superscripts up here. Next we have sp2 hybridized, which means the carbon would be bonded to 2 plus 1. So the carbon would have 3 bonds. And so it would be 33% S character and 67% P character. And this would be a trigonal planar geometry with a bond angle of 120 degrees. Then we would have sp hybridization, which just means 1, 2. The carbon would have 2 bonds, and it's 50% S character, 50% P character. And these P's are referring to the orbital shapes that we've talked about in the quantum numbers. And that would lead to a linear geometry with a bond angle of 180 degrees. So next, let's talk about resonance. So resonance describes the delocalization of electrons in molecules with conjugated bonds. So you'll see this. Okay, these bonds, these bonds, double bonds are able to move around. There's resonance, and this is a conjugated pi system. Okay, in this molecule right here, this aromatic ring, because this could also, in a moment of time, have some bonds here. Okay, so basically, it's just important to note that those double bonds are moving around this ring at all times. Okay, so that's what conjugation means. So that pi conjugate system displays resonance. So conjugation, as I said, occurs when a single and multiple bonds alternate, creating unhybridized p orbitals. So just a quick tidbit here about bond types. We have single bonds, which is 1 sigma bond, which represents 2 electrons. And then we have our double bonds, which is 1 sigma bond and 1 pi bond. Okay, and a pi bond is a sharing of electrons between 2 unhybridized p orbitals. And then a triple bond would be 1 sigma bond plus 2 pi bonds. So if you have that is 1 sigma bond, okay? If you have a double bond, now one of these bonds is the sigma bond and the other one is a pi bond, right? And this pi bond here is the sharing of electrons between 2 unhybridized p orbitals. And then if we had a triple bond, one of these would still, be a pi bond, be a sigma bond, and 2 of them would be pi bonds. So that's just a little background information on the binding and on the bonds, and just the basis of some other things we're going to get into in later chapters. So please understand these concepts, and we'll see you in the next video.